Our group is Decentrailized BlackJack.
I'm Matthew.
I'm Sean.
I'm Matt.
I'm Steven.
So our project is AI-driven blackjack on blockchain. We use AI assistance for two things, for fun play and for an anti-cheat system, which prevents card counting, flags suspicious behaviors, all in an effort to prevent cheating. The design of the system allows you to buy and sell specific blackjack tokens, which are one-to-one with Ethereum in terms of value, or one token equals one way. This prevents overspending or overheating, where one user might just keep playing over and over and over and eventually lose all of their funds. So we kind of reined it in that way. And it allows for users to hit stand, place insurance, and surrender on the cards. The end users for some software are blackjack enthusiasts who want to be able to play blackjack available at any time 24/7, or blackjack beginners who are interested in learning various blackjack strategies with the help of AI. So the way that the project is structured is that the front end has various components which all interact with various smart contracts. The artificial intelligence also interacts with the gameplay, which allows for both cheat detection and AI assistance, and validates the user to ensure that they are not banned, as well as allowing users to exchange value for chips through a cage. In order to play decentralized blackjack, one must first sign in with a wallet. Currently, my account is unverified, so I'll be prompted to enter an age. This ensures that the user is over 21 years old. Now that this account has been verified, you can see that I have a series of games in my history. If I click on this, you can see that I have a bet of 0 blackjack tokens. The game ended in a push, the dealer hand being 5, 6, and 9, and the player hand being Queen and King. From here, I'm going to buy 1 blackjack token by converting 2 way into 2 blackjack token. Now that I have bought 2 blackjack token, I can also sell 2 blackjack token. First, to do this, I must set an allowance that is equivalent to the amount to withdraw or more. Now, once the allowance has been set, I can be prompted to convert those blackjack tokens back into way. Now, there are 2 ways to play blackjack: regularly with a bet or with AI assistance. I have a bet of 0 right now, so I'm given the option to play with AI assistance, so I will select that, and I'll confirm my bet of 0. Now that the bet has gone through, we have generated a verifiably random number and are waiting for that number to be fulfilled. Now that the number has been fulfilled, we can see that I have a 17 and the dealer has a visible 7. The AI at this point recommends that I stand, which I will do. I'll confirm this action. And the dealer has perfectly drawn a 21, so I have lost. And the game is recorded in the history. Now, if I want to play a bet, I can select this value. So I have drawn a 16, and the dealer has drawn a 7. I don't know what to do in this situation, as I have no AI assistance, so I will hit stand. This will draw a new card. 19. That looks much better, so I will stand off of that. And the dealer has 17, and I've stood at 19, so I win. And I've got a payout of 4 blackjack tokens. The account has been loaded with a game history that includes multiple games that are very close, where the player has won with large bets and large blackjacks. For example, game 7 with a blackjack. and has made hits that seem otherwise irresponsible to make given the likelihood of busting. In this case, the user has been flagged as a cheater by the artificial intelligence on the back end, and when it tries to place a bet, the user is no longer verified. So at this point in time, the user can withdraw their tokens, but they cannot play anymore with a bet. They can still play with AI assistance, however. Log, the AI has detected a player as cheating based on these values. In these values, the player starts with small bets and is not doing very well. However, the player starts to increase their bets significantly, all the way up to 3,000 blackjack tokens, and in every case, they make hits that they should not have, statistically speaking, but have been rewarded for them, and as a result have won the games. This suggests that the player has insider knowledge on upcoming cards somehow, and as a result has been flagged as a potential cheater.
Okay, now we'll move on to testing. All testing was done manually, just in an IDE or on Remix. And the results and the hashes for the commits and the dates were all recorded in a spreadsheet that we dynamically updated whenever anything got changed involving the methods and functions that would be tested.
In our test, we use GetGameStake to track the game after betting one BJT token, which creates a request ID. Then the contracts add Chainlink VRF for a random number. We can check the subscription page to check if it sent a request. If it works, it deals a card to the player and the dealer. We can check the GetGameStake confirmed card stealing. Non-zero value means success. Next, we will test hit functions using the same request ID and the hand index. The expected result is that the player's hand will now show 3 cards. This can also be confirmed by checking the GetGameStake. Finally, we will showcase the stand functions. The stand functions signify that the player is ending their turn. After this, the dealer will continue to draw a card until their hand value is greater than 17. And we can check if the game state mentioned the game is ended.
AI was used for 2 different things in this application. First of all, we used it for cheat detection. We used a LSTM-based neural network to do this. You can see that we take every single input, which includes the user action, the dealer card, the player cards, bet size. We run it through a feed-forward network and then an LSTM to get out a single scalar. We need 64 hands for this because just due to random chance, we can't really determine if someone's cheating just based off of one hand. And from here, we then use it to ban someone if they are over a certain threshold. The other thing we used AI for was for AI assistance for players that are not as good as optimal. We give them a AI-generated action that is most optimal at that point. And with that, we used a optimal probability matrix that we generated to do that.
Next up, we have the blockchain component, starting with the authentication module that allows access control. Initially, we planned to use zero-knowledge proof to hide the user's age, but we couldn't figure out how to generate proofs on the web using WebAssembly in time, so we kind of just use a regular age verifications for now. Next up, we have the cage module, which allows the user to swap between ETH and BJT tokens used for interacting with our gameplay. The price of ETH and BJT is always maintained as 1-to-1 via minting and burning. This also ensures that the house never runs out of funds to pay the player. Finally, we have the main core gameplay module, which fetches the random number for dealing cards using the Chainlink VRF functions. We also implement the betting and player interactions functions like hitting, standing, insurance, and surrender. Again, initially, we plan to implement double down and splitting hands, but the code size will exceed the maximum allowed by the EVM machine, so we kind of just went with the insurance function instead.
Okay, now let's talk a bit about integration. The AI was integrated in a couple ways. For the cheat detection, integrated with Web3 Python with both the BlackJack module to grab the game state and the authentication model to ban players that have been determined to be cheating. And the AI assistance module was integrated with the front end with a RESTful API.
Next, for the blockchain integration, as the main backend of the project, we act as the main source of information for the AI and front-end component. Basically, the game states and the game histories are publicly available, ready for another components to fetch from the blockchain.
The front end calls the API endpoints and interacts with the smart contracts under the hood. Additionally, this ensures that the user is only able to call this certain smart contract at certain times, ensuring that there's no confusion over which contracts can be called at any point in time.
This abstracts away the complicated interactions between these components.